Uh, Today we are discussing about analysis of a simple residential building and also the design of residential building, the same thing. So to simplify this, so first just I will try to explain the a plan of a building, but um, in the plan how to keep the columns, beams and all. So that is I'm not discussing because I'm concentrating only how to design this building or the analysis of this building in the Staad.Pro. Okay, so here I have a center line diagram of the building, and the typical floor plan is that this is a G+2 building here. So this is a G plus floor building, G plus 2 building, and each floor height is 3 meters. And the center line diagram, if you observe, so there are three different, two different column sizes are there. First one is 0.23 by zero point 0.3. All columns are 0.23 by zero point 0.3 except this circled one. So these columns are 0.23 by 0.45. And coming to the beams, for to have the simplification, so I have considered the 0.23 by 0.45. And here the 0.23 by 0.45 means 0.23 is the width and 0.45 is the depth. So if I consider a beam here, so the slab thickness generally it is 0.15, and this 0.3 is called beam side. So the beam side which is projecting out from the slab, so that is 0.3, and the slab thickness is 0.1, then all put together it is 0.45, right? So basically due to the availability of the standard sizes of formwork, so those sizes we have to adopt for our construction. Otherwise, if our sizes are different and the available formwork is different, it is very difficult to mold the whatever the required sizes. Right, so that is the reason there are some standards like 0.23, zero point 0.3, 0.375, 0.45, 0.525. This is generally still in the practice. We have the FPS system. So with the minimum dimension of the beam starts with 9 inch, um, 9 inch, 12 inch, 15 inch, 18 inch. Okay, so there are different sizes, in multiples of 3 inches will be there. Okay, whether that is the width or the depth. Then that is how generally the sizes are fixed here, and the fixing of the sizes and all the randomly I have taken here, but there are a couple of procedures we have to consider. Maybe sometimes by practice, just we'll see the span and we'll estimate what is the load is coming onto a particular column, and we can guess what is the column size, or we can calculate what is the rough calculation we do to arrive these sizes of the columns. Okay, so the beam is, if I have a length, let us say 3 meters, that means it's a 12 feet, sorry, 9 feet. So 9 feet means for each foot one inch depth we can keep, so 9 inches depth is sufficient. So that is how also generally we can keep, but for time being we are assuming that these things we have just assumed these values, and we are going to design this. And coming to the loading, so when we are modeling, we will model the columns and beams, and the slab loading, floor finish and all, just I have considered 4.5 kilonewton per meter square, and wall load is considered as 12 kilonewton per meter, parapet is 4 kilonewton per meter, and the live load is floor load you have to give, that's a 2 kilonewton per meter square, because this is from the IS 875 for residential building. And the materials are M25 grade concrete, Fe415 steel. And so here what you have to do is you have to there is a small opening is here. So this opening, it indicates that, so this opening indicates that, so there is a staircase here. So that means we have to apply the floor load only on this L shape. So on this one there is a staircase. So on this 2.5, the extreme, on the top one, so we have to apply some additional load to take care of the slab, the staircase slab, and this one and this one. As strictly speaking, this beam is will be at the mid landing level of the staircase. Anyway, I am not that interested to have this design, but the whatever the slab self weight of the sorry weight of the the waste slab of the staircase, the what is the load is coming, that will be transferred to these columns. So my I am mostly worried about the column design, so that is the reason. So just I am keeping, for simplicity, I am keeping this is at the floor level, and we'll apply some additional load on this to take care of the staircase. And for time being, I am considering all the beams are having the same wall load, and on the roof you will have a parapet, and parapet wall will be 4 kilonewton per meter. All right. So how do we arrive this floor load and wall load 12 kilonewton per meter, and the floor load 4.5 kilonewton per meter square for the from the dead load? Okay, so for this one, so if I consider the 3 meters is the height of the floor, then the 0.3 meters is the depth of the or the side of the beam. So the net height I will get for the I mean brick masonry is it's about 2.7. Actually there is only 1 into is there, and the thickness is 9 inch, that is 0.23 is the thickness, and 19 is the unit weight of the masonry. Okay, so it comes around 11.8. Now I considered it is 12 kilonewton per meter, and from the slab self weight if I calculate, so 150 is the slab thickness, so 150 is 0.15 meters into 25 will give the what is the pressure is acting on the slab. Okay, so that you have to transfer to the surrounding beams and all. And floor finish is 1 kilonewton per meter square. It comes around 4.125. So I have considered in the conservative side 4.5 kilonewton per meter square. So once these things are given, now you have to analyze and design in the Staad.Pro. One more important point we have to notice that, so what is the direction of the these columns? Okay, so these columns, if you look at, so it's a rectangle, the depth is in this vertical direction and width is in the horizontal direction. So that means this is 0.3 and this is 0.2. If the circle one, if you consider, this is 0.45 and width direction it is 0.23. And if you see the all are 0.23 by 0.3, and all are in the it's in the plane direction. If I consider it is vertical, and only this column is horizontal depth from the depth point of view. Okay, so that means we have to orient perpendicular to the remaining things, only this column. So just I wanted to distinguish how the orientation we have to give in the analysis. So from that reason point, from that point of view, I have given like this. Okay, so now we'll get into the Staad.Pro. So I am opening the Staad.Pro here. So there is a new project. First you click onto the space, then I'll say this is residential building. So I'll say this is G+2 building, and the same Staad exercise. Okay, units are meters, force units are kilonewton. Next. And instead of going from the beam add beam, so I use the open structure wizard. So whenever the regular frames are there, then it is very easy for us. So go finish. Right, so actually I am not getting a structure wizard, so just I will try to open the structure wizard here. Sorry, I am not able to open this. Yes, again I will try to open. So this is G+2. Okay, geometry, run structure wizard. Still it is the, yeah, it's open. Right, so this is the run structure wizard, and here there are different models, truss models, frame models are there. I am using the frame models here. Mine is a bare frame, so just I am using the bare frame. And in the length direction, what is the length? Height direction, what is the height? Complete height. And width direction, what is the width? So just if I calculate this, so we will try to calculate here. So in the length direction, this is 2.5, 3, 3.5. So that means it comes around 3 plus 3, 6, 6.5 plus 2.5, that is 9. So I'll click here, and in the length it is 9. And in the height, if I consider 3 plus 4 7, 7 plus 3 10, that is 10.5. Width direction, that is 10.5, and this is G plus 2, so that is 3 heights will be there, so that is 9. And now these are called base. In the length direction I have the 2 base, and in the I mean the width direction I have the 3 base. So I have to make this is 3 and this is 3. So the G plus means ground floor, first floor, second floor, so that means they are also having the 3 plus 3 plus 3, so that is again 3 here. So now I will try to give these widths here. So the first one is, the first bay width is 2.5 here, and the next one is 3, the last one is 3.5 here. So okay, now the height is all are 3, so that 3 3 3 will be there, ground floor, first floor and second floor. Okay, now the along the width, so this is 3.543, so I'll click this. So this is 3.5, this is 4, and this is 3. Okay, then you have to apply. So if you click on this apply, then you will get the frame here. That this frame you have to merge into the Staad. So for that, go to file here and merge model with Staad.Pro, then say yes. And if you open your Staad.Pro, you will get the window like this. So simply you have to press OK. Now the model is there. Now you go to the node to node distance from here, and you measure whether the distances which I got is right or I have to change. So 3.543, so this is fine, and here this is 2.5 and 3, and this one is 3.5. So the dimensions are according to the plan. So, and remove all these node to node distances. Then you have to define your sections. Now the geometry we have created simply by using the structure wizard. Then go to your general. Then the first one is property. So in the just you go and define the property, the rectangular. And if I go back and see here, all columns are 0.23 by 0.3. So this is 0.23 by 0.3. So forget about the orientation, whether the width I am getting in the horizontal or vertical. Forget about that for time being. First you give randomly for columns concerned, right? So then press OK. So the next columns will be 0.23 by 0.45. So this is 0.23 by 0.45. Add. The next beams, all beams are 0.23 by 0.45. Here in the beams, 0.23 is the width and 0.45 is the depth, right? So here YD indicates the depth, so 0.45, and here this is 0.23. So this is for beams concerned. Add. So all three varieties are there. Now if I look at here, all columns are 0.23 by 0.3 except these two columns. So first what I do is I will assign to this property 0.23 by 0.3 for all columns. Then after I will modify the two columns which are circled in the drawing. So for that, first select the property, select beams parallel to Y. All columns are selected, then you assign. Right, so now if I look at the center line diagram, the center line diagram is generally this is the plan. So now I have to choose the plan, and I will, whatever the circled columns are there, I have to select, and I have to give this 0.23 by 0.45. Right, so now I will keep this figure in the plan. Right, then I select the second one and I select this column. Use the control button to select more columns. Okay, so and you please ensure that with whether you have selected only these two or any others are selected. So if I use the isometric view, I can see that there are only two columns are selected, that is my required columns only. Then you have to assign this, and immediately the R1 becomes R2 for these two columns, right? And generally what happens, suppose if I click like this, so the beams are also selected. So that always you have to use you have to drag your by using the mouse, using the pointer, then you have to select only the required columns. Right, now you have to assign these beams. So for that, so go to the isometric view and select beams parallel to X, select beams parallel to Z. Okay, all beams are selected, then you have to assign it, right? And now the orientation you have to check. So it is always better to go to your plan view and you can check the orientation. And if you feel that having these beams, if it looks very difficult to identify what column it is and all, so the simple way of doing this one is just to keep only your columns in the screen on the screen, and you can check the orientation. So that is simply by select your beams parallel to Y and give a right click and go to new view, then okay, so all columns are there here. Now you go to your plan, so all dots are there basically. So now you can check, you can see the section outline from this option symbol. Go to structure and select this sections outline. Okay, now you can see, so 0.23 is horizontal, 0.3 is vertical. These are fine. Even R2, if I consider 0.23 is the horizontal and 0.45 is the vertical. Now the only thing is this, whatever the column is there in the second line, this column I have to turn to 90 degrees without disturbing the other things. Suppose if I want to change that R1, so instead of 0.23 by 0.3, if I change to 0.3 by 0.3, all columns whatever are there, so they becomes horizontal. I don't want that. Only this column I have to change. So for that, there is one option, we have the beta angle. So here you click on the beta angle, create a beta angle, and you give this is 90 degrees. Okay. So this 90 degrees, if you apply, only this column will become horizontal now. So now I select this column and then assign. Okay, now you can see this is horizontal. So even my orientations are fine. So then go to your old structure. Then you can see here the depth wise also, if you look at, so the beam depth also you can see the depth is more and width is less here. So once this is done, I don't want to these section outlines, just I can remove these section outlines simply by clicking symbols, go to structure, go to none. Okay, right? So now in the general the property is over. Next to go to support. So all supports in the bottom are connected to the footings, that we have to consider as fixed connection. So that create a fixed connection. So this is create fixed. Then select only the bottom points. Okay, so for that the simple way of doing is this is the node cursor and here this is elevation. Then I select by having drawing the a square here. Then you go back and check in the isometric view, all dots are selected in the bottom. So now this is F2 and once again I am selecting this and go to isometric view and assign to the selected nodes, assign. Okay, so now the supports are assigned. The next step is load definition. Okay, in the load definition, first I have to create what is the dead load. So dead load here, add, then you have to create live load here, add, close. Okay, so in the dead load, if you go back and see, so there is a floor load, wall load, parapet loads are there, even the staircase load is there. So dead load, the self weight first you have to give. This will this self weight is nothing but the self weight of the columns and beams. Then next go to floor load and you have to give the floor load. So suppose if I give as the floor load, let us say this is minus 4.5 here. So this is minus 4.5 here, and if I give 0 to 9 for all the floors and if I press S, then what you will get is all slabs are selected here. But my if I look at the plan, my intention is not to give this slab, so only the L shape I have to give. So for that the simple way of doing is, so first I will apply the loads for this rectangle, then after I'll apply the load for this rectangle, so that this rectangle will not have any load, the floor load. Okay, so how do we do this? So the simple way of doing is just go and have a maybe a simple right. So what I'm doing is I'm trying to have a small table here. Okay, in this table, let us say there is no filling at all, or maybe there is no, sorry, yeah, there is no filling. And let us say this is x coordinate, this is y coordinate, and this is z coordinate. And I will add one more line here. Okay, this you can do it in your notebook. Okay, so here first I'll select this rectangle. So first you have to write down the coordinates of this point. Okay, so this point coordinate you have to write. Then after you have to write down the coordinates of these two, so that I will get what is the x range and also what is the z range. Anyway, y range is from 0 to 9. Already I have to cover the g plus 2, right? So 0 to 9. Okay, so for that, first go to the node cursor and select this any one of the node here. So this is 2.500. So I will note down this is 2.500. Close. Now you select the diagonally opposite the rectangle, and this is 9 0 10.5. So this is 9 0 10.5. So that means if I want to select the load on these coordinates, so the x minimum is this, x maximum is this, and z minimum is this, z maximum is this. Okay, so go to your dead load and you add the floor load here. The floor load value is minus 4.5 here, and the y range is 0 to 9, and x range is the minimum value is 2.5, maximum value is 9. So this is 2.5 here, and here it is 9. And similarly in the z, 0 and 10.5, this is 0 and this is 10.5. Then if I press add, and you can check only on this rectangle I have, right? So similarly I want to have on these floor, right? So for that you have to select the coordinates of this. So this coordinate is 0 0 3.5. So anyway I'll use another two lines. So this is 0 0 and 3.5. This is 3.5. And the next is the opposite one you have to consider for the rectangle. So this is the diagonally opposite one, 2.50 10.5. So this is 2.50 10.5. So you have to consider only these two coordinates. I use another. Okay, so the x minimum is 0, maximum is 2.5, and the z minimum is 3.5, and this is 10.5. Forget about y, so you need not to worry about this y, because only the x and z is required. So now again I'll go to dead load, add, and go to your floor load, and this is minus 4.5 and 0 to 9, and x is 0 and 2.5. So this is 0 2.5, and z value is 3.5 10.5. So this is 3.5 and this is 10.5, right? Add, close. Now you can see, so only these slabs are having the floor load of dead load. All right, so now I want to apply the self weight. So the simply the self weight, select the assign to view. Okay, right? So the self weight is assigned. Now in the dead load again you have the wall loads. So go back and see here, the wall load is 12 kilonewton per meter. So select this, and wall load I considered it is member load, so that is minus 12. Right, so there is another load on the staircase. The staircase beam I will consider minus 16, and parapet load I will consider minus 4. Minus indicates the downward, right? So these actually these are not physical, so I have to remove this, right? So once again I'll apply, and this is not physical member, this is the member load, and this is minus 12, right? And this is minus 16, add, and this is -4. Don't use this physical member load, you have to use only the simple member load. Okay, so then in the two floors I have to consider, and if you see here, so here you will have the wall, and the second floor also you will have the wall, so that wall load is transferring only on this floor and this floor. So on the roof you will not have any wall load, you will have only the parapet load, that too around the complete peripheral beams will subjected to the parapet. Okay, so that only on the first slab and the second slab I have to consider the wall load, so that I am selecting only the first slab and the second slab. So select this, go to the front view, and go use the beam cursor, select this, and use the control button and select this, and right. So on these two you have to apply the assign to selected beams, assign. But my intention is on this beam and this beam I will have only the staircase load, that is 16 kilonewton per meter, and I have to remove this to 12 kilonewton per meter. So for that, the simple way of doing is select this 12 and toggle load. You have to use this option toggle load, use the cursor to assign, and if the load is there, that will be removed. If load is not there, that will be provided. So that I am removing this load, I am removing this load. Now I have to apply this 16 kilonewton meter on this, and 16 kilonewton per meter on this, right? Then the 4 kilonewton per meter I have to apply on the roof. So the simple way of doing is, now you select the roof and you have to see only the roof. Okay, if all the members are there, while applying the or while selecting the members, you may get confused. So to avoid that confusion, just I want to see only the roof, so that click right, give a right click and press new view, then okay. So now only the roof slab is there. So interestingly, if you look at here, so this whatever the opening is there, above this you will have the enclosure will be there. That means you will have the wall here, and wall here. Above that you will have a roof enclosure. Otherwise what happens, if since it is a staircase, if it is this area is open, then whenever in the rainy season the rain water may through this opening, so that may spoil your house. Okay, so that is the reason we have to close this by raising these walls and having a cover. So with all put together, what I do is I will apply this 12 kilonewton per meter on this one, and this one, and also maybe on this one, because there is a slab also is resting from the staircase. So that, so I am applying this load here. So assign, right? Then after I have to assign these 4 kilonewton per meter on this. So I am selecting this, select this, select this. So all peripheral column beams you have to select. Then you have to assign to selected beams. You have to assign. So the parapet is also assigned. So now in the dead load, I have assigned the self weight and floor load in these two areas. Then the wall load, staircase load, and I have applied the parapet also. So if you want to go back to your original position, so the entire building, if you want to see, there is an option called display old structure. You have to press this, so you can see all these things. Then coming to the live load, so the live load is, I have only the one live load, that is 2 kilonewton per meter square. The floor load I have to give, so that in that one select, use the floor load, and this value is 2 kilonewton per meter, so I have to use -2, and here this is y range for all the thing, it is 9. And coming to the x range, go back here and see the first portion is 2.59, so I am saving this. So this is 2.5, this is 9, and the second portion z value is 0 and 10.5, 0 and 10.5, then add. And the next another set of coordinates I have 0, 2.5, so this is 0, and this is 2.5, and this is 3.5 and 10, these two values. So 3.5 and 10.5. So the same thing, add. And if you want, you can check. So these are fully assigned. Okay, sometimes what happens, so in on the roof you will have a very less live load. So in that case, instead of giving to 0 9, I have to give the 0 to 6. Only the two floors will be selected. For the third floor, again I have to give another live load by giving the range from 7 to 9, something like that. So right, so once this is done, you go to your load case and give a combination. Define the combination here. The combination 3 is, this is 1.5, and you select these two loads into 1.5 plus, I mean add, close. So once this is done, and go to your analysis, maybe you can print all, then add, close. Then you have to run the analysis. So this is, I mean, if any errors are there for the analysis, you can point out what error it is from this analysis. So now if I check here, there are 0 errors and 1 warning is there. You can ignore the warnings here. Okay, so since I mean the floor load I have given, it was asking any sort of one-way loads are there, that also you have to mention. But I am not considering this. I am ignoring this warning. Okay, so now my analysis is perfect. There are no errors at all. Then go to your design. The next part is design. So there is one option below this analysis. You have the design. Select on this. Then immediately you can get some options here like steel. Is it steel design, concrete design, timber design, aluminum design, or any other shear wall design? So here mine is RCC, so that you go to concrete design. And when I click on this concrete design, so there is the design parameters you can see here. So but the current code, you have to give the specific current code here. Since I am using IS456, so my concrete code is IS456. Then you have to define the parameters. So there are a couple of parameters you have to consider here. So out of all these, FC, FI minimum, main, FI secondary, I will note down here. So if you want, you can note down. One is FC, the next one is FI main, and next is FI secondary. Okay, so these are the three. And maximum main reinforcement diameter. So I'll say maximum main. Similarly, maximum secondary, and minimum main, and minimum secondary. Okay, so maximum secondary and minimum main, minimum secondary, these are the minimum properties I have to give for the RCC design. So FC means this is nothing but FCK from our problem. So this value is 25 Newton per mm square. So since I am opting the properties are kilonewton per meter square, I have to give, so that, so this is 25,000 kilonewton per meter square. And the steel grade is 415 grade, so 415000, and these are the units. And FI secondary also the same grade I am using, 415000 kilonewton per meter square. So this is kilonewton per meter square. So in the kilonewton, always you have to use small k, capital N. Then the maximum main reinforcement diameter, the 32 mm diameter is available in the market. And the secondary is maximum secondary, you can use 10 mm or 12 mm, that is for stirrups. And minimum main reinforcement is generally in the beams and columns we use 12 mm. And minimum secondary reinforcement stirrups, we can use the 6 mm or 8 mm. If you are going for the HYSD steel, the 6 mm diameter will not be available. So HYSD steel will start only with 8 mm diameter, so that this is 8 mm. Okay, so these are the values you have to enter. So that first FC, so this is 25,000, then add, and FI main, so that is 415,000, add, and FI secondary, so that is 415,000, add. Then maximum main is 32 mm, add. Maximum secondary is 12 mm, add. And minimum main is 12 mm, add. minimum secondaries you can keep the 8 mm add, right? So now there is a question mark, means we have to assign to all the structures so that all columns and beams will have the same properties. So now select view here, I am assigning to the total view, then select this assign to view, assign, and select this assign to view, assign. Again you have to select all the properties and assign to view. So once this is done, the next one is you have to give the what is the design. So in the design you can use the command option here. So in the command option you can use design of beam and design of column. The design of slab, anyway we are not considering the slab plate element, so that you need not to give. And the takeoff means it will give the what is the total volume of the concrete and weight of the steel reinforcement. So for time being I use only this design of beam and the design of column. So here all are beam elements. So which beam element I have to give like a beam, and otherwise I have to give like a column. So for that, first I'll select the column here. All vertical members I will give as a column. So select beams parallel to Y and you assign it. Right, then select the beams. So select parallel to X, sorry, parallel to X, select parallel to Z, then you assign it, right? So we have given all the properties. Then what I do is I will run the analysis. So here, since I am using a very limited version, I am unable to do the design code, and actually whatever just I will check whether it is yeah, this is because I mean only this version of the stat supports only the analysis, not the design. So if I click on any member, so if the design is over, then you will get a concrete design option here. So since mine is supports only the analysis, but the procedure